Hi all, this is Lakshmi, working as assistant professor in the Department of ECE at SNSCT. So today I'm here to discuss about the lecture series on smart sensors and devices, and the unit which I'm going to discuss is about applications of smart sensors and devices. And let us discuss about the topic Advanced Driver Assistance System, that is ADAS. So, talking about ADAS, so it is an intelligent automotive technologies which is designed to enhance the vehicle safety, improve the driving comfort, and also to reduce human errors. So these systems they use a combination of sensors, cameras, radars, LiDAR, ultrasonic sensors, and the AI algorithms to monitor the vehicle surroundings and assist the driver in real-time environment. So mainly to ensure the safety and to improve the driving comfort. So the advanced driver assistance came into existence with the combination of the sensors, cameras, radars, LiDAR, and other ultrasonic sensors and the algorithms, AI algorithms. So, to discuss about the empathy part of this system, before designing this ADAS system, so we must look into the driver's perspective also. So the many drivers, they are experiencing lot of struggle and distraction during the heavy traffic and long drives. So they will become fatigued and stressed. And the senior citizen or those with health issues are also struggling with lot of stress, and the newly appointed drivers would also feel anxious in the complex road situations. So this is the driver's perspective. And talking about the passengers perspective, so the passengers are also seeking for comfort and the safety assurance, and the family with children will also need extra protection. The child care protection is also required during the heavy traffic. And talking about the pedestrian and road users, so they should also feel safe while they are traveling in the road, and they also face threat from fast moving or distracted vehicles. So they expect cars with ADAS to detect and react quickly by to their presence and preventing the collision. Hence, the main objective of this ADAS system is to prevent the accidents and reduce collision severity, and to improve the situational awareness, assist drivers in complex stressful conditions, and improve the overall driving comfort and efficiency. So these are the objective of the ADAS system. So let us define this ADAS as an intelligent electronic automotive technologies which is designed into enhance the vehicle safety and improve the driving comfort in assisting the drivers and the parking functions. So this is how we define the ADAS system in order to enhance the safety and the efficiency. So the market growth is also been rising in the current era for this ADAS system with the development of AI. So the key features of this ADAS system are, so there are a lot of uh, features like, so we have to go for the traffic sign recognition, the parking assist, and the rear cross traffic alert, the blind spot monitoring, and the automatic emergency braking and adaptive cruise control. So these are the certain features. So talking about the first, that is talking about the adaptive cruise control. Here, it is mainly to maintain a safe distance from the vehicles ahead by adjusting the speed automatically. And the lane departure warning, that is LDW, or lane keeping assistant LKA, so that will detect unintentional lane drift and provides warnings. And this LKA, it can correct the steering. So this is the purpose here. and the automatic emergency braking is also there, and the blind spot monitoring here, it alerts the driver when vehicles are detected in the blind spot zone, and the traffic sign recognition, that is TSR. So that identifies the road sign using camera vision and informs the driver. And the driver monitoring system, this part here, driver drowsiness detection is also being done, and it monitors eye movements, head position to detect the fatigue. And the parking assist here, it has 360-degree cameras, the ultrasonic sensors, etc. for easy parking. So these are all the key features of ADAS. So now the working principles of this ADAS. So there are 5 levels where we can consider this working. So first is level 0, where no automation is being done. So level 1 here comes to driver assistance. So that is steering or speed control. And the level 2 is here is partial automation, steering and speed control. And level 3 will be conditional automation, driver attention is required. And level 4 is high automation, where no driver is needed in certain condition. And the level 5 is fully automated. So the driver is not needed at all. So the ADAS, it falls almost under the level 1 and level 2. So the user interaction, for all such parameters to sense and detect all the signals, we need sensors and cameras, and we need a data processing unit and a control system to for the efficient working of this ADAS system. So applications, so there are a lot of applications of this ADAS in passenger cars, commercial vehicles, autonomous vehicles, smart transportation system, accident prevention in urban mobility, etc. So here the features are shown here: the blind spot detection, the surround view, the park assist, the lane departure warning, traffic sign detection, and all these things are given here in this system. So there are a lot of challenges in ADAS implementation. So first let us talk about the first problem here is the weather dependency. So here we have to depend on if it is heavy rain, fog, snow, and the dust would scatter or block the sensor signal. So cameras would become blurry, and the LiDAR signals would scatter, and the radar reflection is also will be weakened. So this is one thing. And then the lighting conditions. So the low light, the nighttime glare, the direct sunlight, and the tunnel transitions will affect the camera recognition. And the traffic signs and the pedestrians are also would get affected here. And next is if it is not detected properly, and the sensor would be damaged, like dirt, mud, snow, or insects would block the cameras. And the processing complexity, and if it is of higher computational load, it takes time, and the real-time processing is also tough here. And the cost is also high, and the system calibration and maintenance is also a concern. So after this windshield replacement, the bumper repair or camera misalignment, so all these things has to be recalibrated. And also, as I told, high maintenance cost. So today's assessment, which of the following is not a key component of ADAS? So here the sensors, electronic control unit, HMI, and all those things comes under ADAS, and the option is spark plug. Question number 2. In ADAS, the electronic control unit plays the role of, so it plays the roles of processing the sensor data and making the driving decisions. So these are the today's assessment question.